Welcome to tutorial 2 for agent-based modeling for psychologists and those with similar backgrounds. In our first tutorial, we created a very simple model. We created a model in which agents would spawn in the world and they would walk around. We learned how to ask turtles to put the pen down so we could follow their tracks. And in the process, we learned how to write a setup command that was called by a button, and a go command, which would run forever, which would be executed here. We learned how to manipulate various kinds of variables. So you can either pause at the moment and copy the code from this screen, or you can go back to tutorial 1 in this playlist and download the code from the associated GitHub. Today, what we're going to do is introduce a few new widgets, and we're going to create a way for our agents to detect objects in their environment. We're going to give them a kind of sensory apparatus to kind of see or smell or any other kind of abstraction you might wish. And we're going to introduce concepts like breeds and kind of agentic movement, where they might move towards or away from certain things in their environment. So the first thing we're going to do is build directly upon the first tutorial, in which we were using the pen down function in order to make it clearer how our agents were moving. Again, this isn't like a function that is particularly useful for the model itself. It's a good way just for our human eyes to kind of perceive what is happening in the world. And the first thing we're going to do with this is introduce a new widget called a switch. Okay, now we go up to our widget menu and introduce a switch and put it wherever is convenient. And here I'm going to call this trails. We can call it whatever we want, but I'm going to use the term trails, and you can see that when we use it, we can turn it on and off, rather than typing the command pen down in the command center. Now, we're going to introduce our first if statement. There are two places we could introduce it, and I'll do both, even though one is more efficient than the other. First, we're going to introduce our if statement into our setup procedure. I'll make this a little larger so you can follow along at home. So you can see here when we call setup, we clear the world. We create 10 turtles with unique XY coordinates, set their size, and we allow them to have different colors. If statements and other kinds of statements like repeat or while are pretty standard in just about any programming language, and the same is true here, especially if we have a switch where something's binary on or off. Now we've created our variable, it's called trails, and so we're just going to say if trails equals true, okay? And we open and close our square brackets. And here in the setup procedure, we can now implement our code. So if trails equals true, we can ask our turtles to do something. In this case, pen down. Now this is our first second tier in the hierarchy of coding. You can see that Netlogo does a really nice job of automatically indenting. If it doesn't, just highlight everything and hit tab and it will automatically indent things to the same levels. I like to keep all of these on separate levels because it makes things a lot clearer to work out what you're doing and what's acting on whom and at what level. So here we can say if trails equals true, we will then ask our turtles to put the pen down. So trails is off, we hit go, everything is normal. If trails is on and we hit setup, their pen is down. Now, if we turn this off and hit setup and then turn it on and press go, the pen down function has not been initiated. And that's because our if function is called from our setup function. We might want this to be more dynamic so that it can so that it can be called whenever we switch it on or off. Now, we're not going to create a unique function just to detect this when this state changes. There are ways to do that, but it's probably unnecessary. Our model is fairly simple at the moment. So rather than having this called only through the setup, we're going to call this in the go. Now, so I've just copied and pasted that straight in there. And what we have here is ask turtles. So when go is run, and it's currently a forever button, so it's going to keep going and going and going. We're going to ask our turtles to move forward, choose a semi-random direction, and then repeat. But we're also going to check if trails equals true. And if it is true, we're going to ask our turtles to put the pen down. So you can see here, if trails is off and we hit setup and we hit go, they start moving and they put the trails down. So it's dynamic. Now, if we turn it off, nothing happens. Okay, this is because our function in Go here only specifies what happens if trails is true. Nothing updates if we turn it off. And so in addition to the if statement, we can now, well, one solution, and this is inelegant, but it's a demonstration of a broader concept. If trails equals false, we can ask turtles to put the pen up. Okay, and so now, needs an S. And now, if trails is true, they'll put the pen up. And if trails is false, they'll put the pen down. Up, down. Okay, nice and simple, does exactly what it says on the tin. However, this is slightly inelegant. And in addition to an if statement, let's pull up our Netlogo dictionary. And we know that let's pull up our Netlogo dictionary. Now we know that basically all coding languages are going to have an if statement. Here it is, okay? And so that's if Boolean reports true, then command is run. If Boolean reports false, then nothing is done. Now it's going to show us an if-else value. So if-else Boolean equals true, do a command. But if something other than the command is true, okay, or if the command is something other than true, if the command is false, for example, you can do a separate thing. And so if we're going to use if-else in our code, we can do it like this. If-else, let's delete all this so we're not confused by it. So if, we can see here when we click on these square brackets that they identify which ones belong to which. So these belong to the ask turtle, this belongs to the if statement. Now if I write if else and hit check, it's going to tell us it's missing something. Expected 3 inputs, true, false, there's our true or our false, then 2 command blocks. So if it's true, we ask turtles to put the pen down. Now we're essentially going to write the commands for the else. Now remember, we know how to annotate our text using semicolons. This command is run when trails equals not true equals false. Okay. And here we can say ask turtles pen up. So if we annotate this, just so we fully understand it, if the trails switch in the interface is true or on, then ask turtles to put their pen down. If trails equals not true, or if it equals false, ask the turtles to put the pen up. We check it, it seems to run, and just as we expected, up and down, up and down. Now, this is slightly inefficient code because it's being called every single time the go command is run. But this is a very simple model and we're not really going to concern ourselves with it. And we're not going to use it too much anyhow. But it is a nice demonstration of how the if-else function can work. Now, it becomes kind of useful at this point in time to talk about how time is measured, or rather how the go function works a little bit more. Now, we've discussed the whole interface overall, but you can see here that there's a thing called ticks. I might have also used the word ticks a little bit while trying to describe the process so far. Each time the go command runs, so if we turn this off from being a forever function, and I can call the go command 1, 2, 3, 1, 2, 3. Every time I go, essentially the model ticks. Okay, and ticking is just a way of counting how many instances of the overall functionality have been executed. But right now it's not recording, it's kind of running blind. What we're going to want is at the end of every go procedure, we're going to want to tick. Okay, we're going to want the model to record that it's executed the go function, this kind of master engine of our model, and then it's going to iterate and iterate and iterate. If I put tick there and hit check, should be fine. We now have an issue. We want it to iterate ticks, but what it's telling us is the tick counter has not been started yet. Use reset ticks. Now, I know what that's all about, but let's look it up together. It's told us to use a command that we're not familiar with. So, reset ticks. We can find that by just hitting Control F, and it's in the world function. Reset ticks resets the tick counter to 0. Sets all plots, then updates all plots, and so on. This will be useful when we do more plots later. Normally, reset ticks goes at the end of the setup procedure. So this is really useful. So what we have in our setup procedure is clear all. Clear all resets all of the information in the model, except apparently reset ticks. Okay, and we'll show you why that's useful in a minute. So now in our setup, it clears the world, populates it with what we want according to our settings. We'll get rid of that because go function deals with that. It clears the world and resets the ticks, and then in our go, it does what we want it to do, and then it ticks. So we're not clicking forever here. You can see every time I click it, 4, 5, 6, 7, this number gets higher. That's very useful. Now, if I hit setup, it just resets back to 0. This can be very useful, or this will become basically necessary at later points with more sophisticated models, just to kind of know how fast or long your model is running. And we're also going to want to schedule events at various points. And now you see if I click go and I run this at normal speed, very quickly, we're at 56,000 ticks. Okay, and the screen becomes faster than human perception. We reset it, goes back to 0. So as with tutorial 1, when we said you're almost always going to start with a setup and a go button, and then within that setup you're going to have clear all and reset ticks. These two things are basically two things you're going to write at the beginning of every setup procedure, and then you're going to add whatever else you want here for your model. Okay, so we're starting to build a more sophisticated, more robust model as we move through. These are the normative and kind of important things we need to get right in our Netlogo code. Let's zoom out. So now we're starting to look like real code, which is cool. Now we want to introduce something in this environment for the turtles to avoid. Now, yes, in our tutorial 1, we were talking about how these are turtles. Okay, if we inspect a random turtle, we can see that its breed is turtles. Netlogo uses the variable called breed to dictate what group or agent set turtles within the model belong to. So let's visit our Netlogo dictionary and let's look at what a breed is. So we come here to turtle variables. These are all the default turtle variables, all the variables turtles have kind of natively. We can give them more variables later, but these are the ones they always start with, and we see that there's a breed. You'll see also later that other things have breeds, that links have breeds, but we're not going to deal with that right now. So let's click on breed. Breed. This is a built-in turtle and link variable. It holds the agent set of all the turtles or links of the same breed of this turtle. So if we want to implement two different kinds of breeds, like cats and dogs, it's very simple. At the top of our code, we specify breed and then state the plural form and the singular form. So instead of turtles, let's say we had cats. Let's say we want to ask cats, all of the cats, to do a random walk. We would ask cats. But if we wanted to ask just one, we'd probably identify its ID, I don't know, like the 10th cat, and we'd go ask cat 10. And then we would just be asking that singular instance of the agent to do something. Okay, so this is quite straightforward. We want two kinds of turtles, and we want our existing turtles to interact, sense the environment, and then interact with it in some way. So we're going to want to create an obstacle. Let's keep things nice and simple, and let's just implement a rock. So we want a breed of turtles called rocks. So we want to type breed. Okay, this is where we declare what kinds of breeds will be in our model. And I said that we need to go plural and then singular, rocks and rock. Okay, so now our model, though we haven't asked rocks to exist or to be anything yet, our model can entertain a distinct breed of turtles called a rock. Now, rocks are turtles. Okay, and this is where I said in tutorial 1 I might use the word turtles and agents interchangeably. Once we have more than one breed, agents becomes a lot easier to kind of work with. So rocks are turtles. So now if I ask turtles to do anything, I'm asking normal turtles, our little triangles, as well as our rocks. But we want to avoid that. So we want to change our turtles to something else, something that we can refer to kind of in a way that we won't get confused. So we're going to want our little triangle creatures here, our little triangle agents, to be something else. I like to use the word peeps, like people, okay? It's just a nice way, I personally, this is just my own idiosyncrasy, use this to keep track of kind of my focal agent, okay? And I do like to make sure that these things aren't like too literal, like people or whatever, a breed, people, person, because models are abstract. And so I like to remind myself that these things are abstract. If I was being really true to myself, I would call this something like obstacles and obstacle, okay? Because they're not rocks, they're just obstacles. But for the sake of clarity in this tutorial, we're going to stick with something a little bit more relatable, although I would generally advocate to go for greater degrees of abstraction to avoid personal confusion. So now, if I ask turtles to do something, I'm going to ask all turtles to do it, and that includes rocks and peeps. What we actually want to do is change everything so far that is turtles to peeps. So we want to ask our peeps to go forward and then do a little wiggle turn. We want to ask our peeps if trails equals true to put their pen down and pen up. Now what we have here is create turtles. So let's see what happens if we don't update that. Our check function works fine. And while our setup works, our go function doesn't work. That should make sense because setup is just creating the turtles. And our go function isn't executing because there's no peeps to ask. Now we've created turtles. We're going to go back to our dictionary and find our create turtles function. And we can see here that we can create turtles with a number and a command, which is something we've done, but we can also create breeds. Okay, so instead of making turtles, we probably just want to create rocks. Not rocks. We just want to create peeps. Now, because this is a new variable that we've created, and even though create turtles turns a color to show us it's a primitive, because we've introduced a new variable, it's not going to change color, but it is going to work. Create breeds, create peeps 10. they're called, and now they move around just as we would expect them to do so. But we want to also create some rocks. So it's quite straightforward. Create rocks. We want to create number and then give them a command. So let's create 10 rocks and let's give them a command. We can just copy and paste this, right? We want our rocks to show up at random coordinates. So let's just copy and paste that. Now, let's have their size 2, nice and big so we can see them, but we want them to look different from our turtles. So if we create them at the moment, they look exactly the same. They don't move because we don't have any rock commands, but they look exactly the same. So let's make them kind of rock-like. So we know that we have turtle variables. We know that we have turtle variables, and we know we have a thing called shape. Okay, and shape, we can say set shape to be a wolf or something. Now, if we want to inspect these things, we go up to our tools. We can go to our turtle shapes editor, and we can import things, but we can look at all the libraries. There's lots of little shapes here, smiley faces, leaves, people, trees, whatever. We're going to keep it simple. Set shape circle. Okay. Now I know circle's a default. You can find it in there. We put it in quotation marks just by convention. But now we're going to make all of our rocks created into a circle shape. And we can easily tell the difference between them. They're not moving because they have no commands, but they also look different. But let's just go another step further. Set color. We know that turtles also have color variables. We dealt with that up here when we tried to make all of our turtles red yesterday. Let's just make them all gray because rocks are gray. And now we can very clearly see what is happening in our world. I'm actually going to make them a little bit smaller because that's just looking a little bit busy to me. Great. So now let's just demonstrate the principle before. If I ask turtles to do something, because rocks and peeps are all turtles, set color red, everything turns red. We don't want that, okay? We want to keep referring to peeps and rocks as distinct entities. And so now we need to have our turtles sense the rocks. As you can see, and we can demonstrate this with our pen down function, we can see that turtles can move straight through rocks. They are not caring, interacting, detecting them in any kind of way. So what we have to do now is identify a way in which our turtles can sense their environment. They don't have eyes. There's nothing built into them. These might be germs. They might be people. They might be embers in a fire as far as the model is concerned. So it makes no assumptions about what their sensory capacities are. We have to build that in. But before we do that, we need to consider the construction of the world, because for things to sense the environment, we're immediately going to have to think about some of the important assumptions in that world. How far away can they sense things in their environment? Do they have perfect omnipotence and know exactly where all of the rocks are at all times? Or can they only detect rocks that are near to them or kind of middle distance? Can they detect anything else in their environment? What kind of, for lack of a better term, cognition or sensory apparatus allows them to recognize and classify objects? Which is also where breeds come in, because we're going to want our peeps to identify our rocks, okay, and to identify where they are in the environment. Let us revisit our dictionary again. Let's go down to turtle related, and we can kind of scroll through these to kind of determine if there's anything here that will allow us to see something in the environment. We can see things like inspect, maybe. Inspect agent opens an agent monitor for the given turtle. Okay, that's not what we want. That's not a thing for the turtles to inspect other things. That's a thing for us to inspect the turtle. We maybe look at is turtle, okay? Is turtle question mark. So is something an agent or a turtle? This is a question. Is something true or false? It's kind of an if statement. Reports true if the value of a given type. So we can say like, is rock true? But we haven't detected it yet. We need to detect it and then determine whether it is in fact anything like a rock or a peep. Now, the trick here is that there's actually nothing here that does exactly what we want. We've already got if statements. We understand what an if statement is. If something equals true, then run a certain kind of command, or if else, if it's not true, run a different kind of command. Now, what we actually want is a command called incone. But first, we're going to deal with this thing in radius. Okay. In radius, agent set in radius number reports an agent set, okay, a group of agents, rocks or peeps or whatever we ask, say this could be a rock set or a peep set, reports an agent set that includes only those agents from the original agent set whose distance from the caller is less than or equal to a number. So, ask turtles or ask peeps, ask patches in radius 3, set p color red. Okay, so basically what's happening here is it's asking turtles to ask all of the patches within its 3 units of distance from it to set its p color red. This is very useful code because what we need to understand is how big our world is. So in tutorial 1 we looked at our settings and we understand that our world is 33 by 33. But what does that mean? How big? What is 33? So if we ask our turtles, or rather I'm going to ask one of turtles. So if down here, if I wrote ask turtles, I'm asking all turtles to do this, but I don't want to do that. I just want to ask one of turtles, ask patches in radius 3, set p color red. Now we use p color because patches are different from turtles. Turtles have color, patches have p color. Oops, I have got an extra bracket where I don't need one. And you can see here, around this turtle, that this is 3 patches out. So there's a patch, 5, 1, 4, 1, 3, 1. Okay. We can run this again. And that's the range. This is what 3 is. We could change that to 6. Let's make this green just so things are clear. It's twice as big. Let's try it again. Twice as big. Okay, and let's do it once more. Let's make it 12, and let's make it blue. 3 times as big. So, these are essentially the pixels of the world. Our world is made up of little square pixels, and when we talk about range, like something being in radius, we're talking about it being within a circle that has a 3 pixel radius or a 6 pixel diameter, not including the pixel, usually the pixel on which the agent is standing. It's not precise, it's not millimeters, it's not centimeters, but it is a reduction and an abstraction that is useful. And generally we don't need too specific a calibration on this kind of thing anyway, but there might be cases where that is. So if we have a model where agents walk around and we ask one of the agents to look at pink, and we ask one of the agents to detect things in radius 3, that's everything it's going to detect at that moment. So where this splotch showed up is they would have detected food potentially. So in our Go, we're going to want our turtles to start doing things. But if I wrote something, if I wanted to put the commands in here, in Go, we're going to ask our peeps to walk and then do a little wiggle and then check if they should have their trails on or off. This starts to get really busy. We'll tidy this up in a minute, but we'll create our command for the moment and then we'll go back and do tidying up, which is a necessary part of this kind of coding. So what we want to do is ask our peeps whether they can detect anything in range 3. So we want to ask peeps, okay, as before, ask peeps, forward 1, right, random normal 045. So ask peeps, open our square brackets and close. we saw this term just before, if any, we had an any, okay? And it's if any turtles with color equals red report that there's a turtle with at least color equals red. So this looks like we can borrow this kind of code. If any turtles, now we don't want turtles, we want rocks. So if any rocks in radius 3, print I see at least one rock. And we'll close that. So if we now go and run this, I'll clear this because we'll see a lot of things popping up here. We can see lots of turtles telling us they can see at least one rock. So this is good. We have now got them to be able to sense something in their environment. But we don't need them to just shout that out. We're going to need them to do something with that. We're going to need them to do something with that. And for the moment, we're going to ask them to kind of avoid rocks, right? So we might get them to, we want them to kind of essentially turn away from the rock. We want them to run away from the rock. We'll keep this as simple as possible. So there are a couple ways we could do it. We could say, we could use our right random normal and just make them turn 180 degrees, for example. But if we got them to turn 100, well, let's have a look what happens if we do that. Right, 180. So first of all, there's a problem here. This code will work, okay? But we don't really see, oh, we do actually see them avoiding. That's neat. We see someone caught down here. We see someone kind of trapped around a rock. So it's not really avoiding it, but almost seeking it out. This one seems to be hanging around the rocks way too much. We see over here, one of them was hanging around the rock way too much as well. So they're not really avoiding it. Something's happening, but they're not doing exactly what we want. And that's happening for a couple of reasons. In our go command, we are asking peeps to step forward and then do a little random wiggle. And then we're also asking them again, if they see any rocks in radius 3 nearby, to turn backwards. But the problem is, you can see, because of the little up and down wiggle here and a couple of other places, because it's in radius, they're detecting things in a circle, right? Which means they're detecting things in the radius of 3 in front of them, to the sides of them, behind them as well. So if they're close, like this big green one's a good example. If it's close, it's always going, I see at least one rock, I see at least one rock, and then it's just turning 180, turning 180, turning 180. It's not avoiding it, it's just having a little bit of a meltdown as it's going. So we don't actually want something so specific as in something so broad as in radius. In radius is not that useful for us. So let's go back and we can look at this other option which seems promising, which is in cone. Now, if a radius is a big circle around an agent, a cone is a subsection of that circle. So we can ask an agent set in cone distance angle. So this reporter gives you the turtle a cone of vision, okay? Very useful for us, a cone of vision. The cone is defined by the two endpoints, the vision distance, which is the radius, and then the viewing angle. The viewing angle may range from 0 to 360 and is centered around a turtle's current heading, which in this case is generally, let's clear this up, the pointy tip of the triangle. So if we had in radius 3 distance and then angle 360, we've essentially recreated the, if we had in cone distance 3 and then angle 360, we've just recreated in radius. We don't want that. We just want them to see kind of what's in front of them. So we might have an angle of 45. So instead of if any rocks in radius 3, we're going to change that to in cone 3, and let's say a 45-degree angle. Quite a narrow spectrum. Now we can also test this by asking asking our agents not to ask all the patches in radius 3 to set color pink, but in cone 3 and 45. And you can see here that this little yellow one is got a short distance and a pretty crude little vision right in front of it. Okay, so you can see they're all now slightly detecting what's in front of them. That's actually pretty small. So let's make that distance a little bit bigger. Let's make it 5, and let's make that cone a little wider. Let's make it 90 degrees, okay, and a big square angle in front of them. Let's change these variables. And there we can see that's actually asked the rock. That's actually asked the rock to detect for us, and we don't want that. So let's change that from ask one of turtles to ask one of peeps. And we can see the blue one has a much bigger field of view. It's seeing further and seeing wider. Okay, here's a nice example here. So it's got a much more refined set of detection capacities in front of it, and it's not asking anything behind it. So this green turtle probably can't, well, definitely can't detect this rock at the moment. But this yellow one can detect this rock. Okay, so if ask peeps, if any rocks in cone 5 and 90 turn around, turn 180 degrees. Now let's see what happens. Okay, so what we're seeing here is that the turtles are managing to detect and then avoid the rocks. You can see, because our trails are down, that the turtles aren't in fact walking across any of the rocks. Because the range is so large, they're avoiding them quite dramatically, which is kind of neat. So if we go in here and actually change this down to like radius 3, we'll see the difference. We'll start seeing them creep a little bit closer, okay, because they're not able to detect things from as far away. Now, depending on the needs and the demands of your model, you can move this around and change these things. Our agents are not smart at the moment. When they detect something, they just move in the opposite direction. But you can see that their paths, they are deliberately and agentically avoiding these obstacles, which is very neat. Now, at the very end of this tutorial, we're going to implement a way for these turtles to for us to dynamically change how far they see and even how wide they see if we feel like it from the interface, kind of like we can manipulate trails. But first, we need to go back here and go, look, this is pretty messy. What's happening here? We want to tidy things up so that we can have more control and avoid more errors. And we can also see that we have in our Go, we have 2 commands that are kind of doing the same thing. We have asking peeps, well, we're asking peeps to do something twice, right? And we're asking them to kind of do similar things, which is move and turn, and down here, turn. So we want to tidy things up. It's very important that you tidy as you go. And so I'm going to teach you how to create a command from within the code. So we have our setup functions and our go functions, and these things are separate. I like to start making things a lot tidier and annotating them at this point. So create some semicolons and say setup code. And this allows us to begin to identify, just visually, quickly scan through where things are happening. Go commands. Okay. And so any kinds of commands we want to run that belong to setup, we'll do here. And everything we want to do in Go, we'll do down here. We can have other ones that are for plotting or other kinds of outputs. But let's keep things nice and simple. Let's create in our setup a command to create all of our peeps. Make the peeps. Now, if we click check, okay, it's going to want to try and execute that, but it's saying nothing named make the peeps has been defined. As with tutorial 1, we know how to create these kinds of commands. So we want to go create make the peeps, and we want to end it. And now it's going to run. Okay, it's going to execute this command, which is actually empty. So it's going to execute it, and everything will run just fine. But if we take some set of commands and put them inside this other command. Okay, make, so it's going to go setup, it's going to clear all, then it's going to attempt to run make the peeps, and then it's going to create our peeps 10. We click check, everything works fine, and everything works exactly as we expect. We can create the peeps, and let's go make the rocks. We do it exactly the same way to make the rocks. We paste that code in there. Click setup, it's going to run just as before. And so now our setup command is nice and simple. We have clear all. Now we'll annotate it and go clear all. This clear all resets the information. This creates the peeps. This creates the rocks. This resets the ticks. And down here, we can now start modifying things without fear of confusing ourselves or introducing too many unnecessary errors. And we'll do the same thing down here in Go commands. So we have this, which is kind of a moving command. We've got our trails, and then we have another kind of moving command, and then tick. So let's simplify this. We want to create a command that's something like move the peeps. We want to create detect rocks. And probably at the end, we want to create a trail check. Okay, so to move the peeps, and to detect rocks, and to check to trail check. And now we can kind of take everything to move the peeps. Let's move our move commands down here into move the peeps. Let's move our detect rocks into our detect rocks command. And let's move our trail check into our trail check command. And now we have a much simpler Go thing. We have a much simpler Go block. When we look at our Go, the order of things that happen is we move the peeps detect rocks, and they do a trail check, and we've moved all that. Now, we might also want to consolidate our detect rocks, because our detect rocks is kind of also a movement function, into the same block. That might be a good instinct initially for this very simple model, but when we have our detect rocks, we might want to do more sophisticated things with it, and we might not want it to be embedded within the move the peeps, because then things get complicated like they were previously. So for the moment, we're going to keep these things separate, and we'll make a decision about consolidating them together later. The other thing about moving these things out into their own separate command blocks is if we look at procedures, it now lists all of our 2x, all of our procedures, so that we can jump to any single section. And once you have like a dozen, 2 dozen, 3 dozen of these things, this can become very useful if you're just trying to navigate through this whole space. So the final thing we're going to do here is to kind of create some dynamic interaction in our model. And by that I mean specifically, we want to dynamically change how much they can see, how far they can see, and how wide they can see. And we want to do that from the interface. We know how to create widgets. Okay, we've done that before. We're going to look at our widgets and go and review them. So we see that there's sliders. We haven't used one of those before. Let's see what it does. Let's call this, we'll just call this vision for the moment. And we can see that down here it's 0, up here it's 100. We can dynamically change these values as we go through. Okay, so we've created a thing called vision, and again, when we go into it, we can change these variables. So the minimum is 0, or it could be -2 for all we know. So we're going to make it 0. We're going to make the increments 1. And let's make our range, our maximum, 10, because we already know that like 9 and 12 is already quite a large, if we make this 12, that's really quite large. So we're going to make it slightly smaller than that. If it was 100 or if it was 33, for example, it's going to be the entire screen. So by creating a widget here in the user interface, what we've actually done is declared a variable, and this is specifically called a global variable. We're going to deal with global variables in the next tutorial, but this is a fast and dirty way of creating a variable, a global variable. We've called it vision, and it's got a value between 0 and 10. If we want to dynamically use that, we can just change that 3, which was always going to be 3 always and forever. We can just type in vision here, okay? And this, by typing in vision, it's going to pull this number, no matter what it is, at any time. And because it's coming from the go commands, okay, in detect rocks, it's doing this every single tick. So if we clear this, I'm going to slow it down a little bit, set the trails on, speed it up a little bit. You can see here that 7 is quite large. They're able to detect the rocks and move away from them. Now, if we shrink that, we change the distance at which they can view these things. Okay, and if we move it up to 10, and you can see here that when the vision is very high, that they're going to be extremely limited in their ability to move, because they're constantly trying to move away from all of these obstacles. So what have we managed to accomplish in this tutorial? We've created 2 new kinds of widgets in our interface, and we've learned that they are global variables. We've been able to make things dynamically interact based on our needs through interactions with the interface. Okay, we have learnt what an if statement is and what an if-else statement is, and we can execute conditional commands. We have gone through the logic of creating of detection for our peeps. We've identified what breeds are, so that when we ask our turtles to do things, we know that we're asking our peeps to do something or our rocks to do something. And we've looked at the importance of making sure that our code is nice and clean and tidy and separated, so that we can change things on the fly. And so here we are again at the end of tutorial 2. If you're finding this useful, like and subscribe. Feel free to drop comments below if there's any questions you have or anything you'd like to see in future iterations of these tutorials. We will be building upon this to try and build up more sophisticated kinds of behaviors in our peeps, in our agents, in our turtles, so that they can perhaps seek out objects in their environment and then interact with those objects, or even interact with each other in a dynamic manner. But those will be for future tutorials, so please stick around.